short demo, I will be showing NFV telco deployment for OpenStack with SR-IOV and DPDK features. What you are seeing here is an internal switch 10 GB and two bare metal computes sharing the same hardware and the same NICs layout. In the compute OVM SR-IOV DPDK 0 and not 0, there is only one VM named T-Rex server with two SR-IOV PF. Those PFs are VLAN tags, port 0 with VLAN 9 and port 1 with VLAN 10. On the right we have compute OVM SR-IOV with DPDK 1, currently with only one VM named SR-IOV VF-DUT VM. By the way, DUT stands for Device Under Test. Following VM has two SR-IOV VFs and there are two tagged with the same VLANs, each port with a dedicated VLAN. Now, what we are missing here is the ability to connect to those VMs for the management purpose, like installing the relevant packages for tuning, performance, and automation. As this is a telco-tuned environment, we can't just add any available network device, simply because it will create unexpected kernel interrupts, which will impact our performance flows and even can make a general degradation. So one of the options that we have is to use DPDK. Let me take this opportunity and explain how we configure DPDK and how to use it. The first layer is the PMD threads, which consist of the APIs that run in the user space and assign it to a dedicated CPU per each NUMA. They perform tasks such as continuous pooling of input ports for packets, classifying packets once received, and executing actions on the packets once they are classified. The next layer is the Open vSwitch with DPDK. We're creating here a DPDK bridge named DPDK1, and then a vhost user which is added as a DPDK management network to instances with an attached feed. So with this configuration, we can assure that our instances will be properly isolated from the kernel interrupts. For sure, additional tuning and configuration are needed, but this is the basic first requirement. Okay, now let's add a DPDK management network to the SR-IOV VF instance as well. Lastly, let me add additional DOT scenario, a DPDK VM on the NUMA node 1. Compute OVM SR-IOV DPDK 1. As with the previous configuration, here as well we are using dedicated NICs. In our current case, it is a Mellanox 25 GB with separate DPDK bridges and vhost user ports. As with PF and VF SR-IOV ports, they are also tagged with the same VLAN 9 for port 0 and 10 for port 1. An additional thing I'd like to mention here is that in each DUT VM there is a DPDK application called TestPMD, which is able to unbind SR-IOV and DPDK ports from the kernel space and bind them to the user space. And we use these DPDK libraries to take incoming packets from one port and forward them to another. Now it's the time to explain the perf packets flow. T-Rex is sending a packet from port 0, VLAN 9. It goes up to the switch. From there it goes to port 0, VLAN 9 on the DUT VM. TestPMD application taking this packet and forward it to port 1, VLAN 10. And from there it goes back to the switch and reaching its final destination on the port 1, VLAN 10 in T-Rex. Then T-Rex is counting how many packets I have sent and how many packets I actually received or lost with latency and jitter. So this is an example of just one packet flow, but actually we're sending packets in the bidirectional mode, which means both ports are sending and receiving traffic simultaneously on each port. And in this specific scenario, we are going to send 30 million packets per each port. So total for both ports, 27 million packets per second. And with that, I think we can finish this short demonstration. Before we are done, I'd like to point out that there are 2 additional demos that I will send: the resource creation for the performance flows and the performance for the SR-IOV DPDK scenario. That's it for today. Thank you for your time and have a great day. Cheers!